Want to characterize the distortion of a LiDAR sensor in the presence of a cover lens? Let me show you the new LiDAR sensor feature in ANSYS SPEOS. We'll get started with an automotive LiDAR sensor. I will show you how to use this new feature to detect and calibrate distortion introduced by your cover lens. To get started, we will study the LiDAR perception of the scene without the cover lens. A LiDAR sensor is implemented inside its headlamp module on its front left corner. A LiDAR sensor contains an emitter, sending modulated light beam, usually in infrared for automotive applications, in the scene, and a receiver collecting photons back reflected on road objects. On the depth map, we can measure the distance of an object. For example, the direction sign is located at about 14 meters. In a real condition, the LiDAR sees the scene through a cover lens, which brings a distortion on the perceived image. This can be very dangerous if the distortion is not well calibrated. To do this, a predefined pattern can be used as a target to provide distortion information inside of a LiDAR sensor field of view. By comparing between with and without the cover lens, the distortion can be well calibrated in the presence of a cover lens. Water drop on the cover lens can also have an impact on the reliability of the LiDAR detection. With the LiDAR simulation in ANSYS SPEOS, this impact can be qualitatively and quantitatively analyzed and thus get controlled to reduce the risk.